Alright, so moving on, so this is example number 4, page 560. That says use reference angles to evaluate functions. So we're going to evaluate sine of 4 pi over 3. Okay, so first we need to find the reference angle. In order to do that, we need to know which quadrant. Okay, so if you draw the unit circle, you don't necessarily have to right now, but you just need to figure out where this is. Okay, so of course, here, because this is pi, and we have a denominator of 3, pi is the same as 3 pi over 3, right? So that means that 4 pi over 3 is past that. So, again, it's not going to be perfect. I'm going to put it over here. Okay, so that means it's in the third quadrant, 1, 2, 3. Right, so what would be the reference angle? So the reference angle, remember, is theta prime, is the acute angle formed between the terminal side and the x-axis. Okay, so how do we find that? That would be theta prime equals, okay, the entire angle theta, this is the entire angle theta, the entire angle theta minus 180 degrees, right? So if you take all of it, take away the 180 degrees, which is the straight line, you'll just be left with this little portion, which is the reference angle, okay? Now, because it's given to us in terms of pi, we're going to do theta minus pi instead of theta minus 180, okay? Remember that it's the same thing, all right? Degrees versus radians. And so, we just have to plug in. So now, go ahead and plug in. So our theta is 4 pi over 3. Take away pi, which is 3 pi over 3. And it's pi over 3. Again, you could just do this logically as well. Okay, this 4 pi over 3 minus the 3 pi over 3 would be this distance right here, which is pi over 3. Okay, so pi over 3 is a reference angle. Awesome. So, you have to think about, now you have to think about sine, right? Remember, sine is the y value. So if you are in the third quadrant and you had a point, okay, just think about the signs, right? So the x value would be negative, right? X value would be negative, and the y value would also be negative, right? And so sine will be negative. So the sine 4 pi over 3 is going to be negative, and it'll be equal to the sine of the reference angle, which is pi over 3. Alrighty. Now you should know pi over 3. Pi over 3, okay, here we have 30 degrees, that's pi over 6. Remember, I went over these last class and I said these are very important. 45 degrees is pi over 4, and 60 degrees is pi over 3. Okay, so if I do this correctly, you should have actually been more like this. Alrighty, so then this part we should know again. I told you guys to look over the unit circle. It's very not complicated to know. You just need to know the first quadrant, and then the rest is going to be essentially the same, just different signs. So you would check the right x value to have the right sign, the right y value to have the right sign based on the quadrant. Okay, so here this 30 degrees pi over 6 is the square root of 3 over 2, 1/2. Pi over 4, square root of 2. And later on, I'll actually show you why it's those values. We probably just memorized it. I'm guilty of that. I just memorized it and I never knew why. But it goes back to right triangles, so we'll do it later on. We'll have a right triangle. We're going to prove why these are the x and y values, at least of the first quadrant, and the rest kind of goes from there. Okay, so just judging from here, what is the sine of pi over 3? It would be the square root of 3 over 2, and then of course it'd be negative. Okay, so we did it, but we solved it by using reference angles, which is what is needed. Okay. These questions get pretty fun, as long as you know how to find coterminal angles, reference angles, just use definitions. Okay, of course you know your unit circles, your equations, your trig functions, all that. Okay, it all comes together. So now let's look at part B, which is the tangent of negative 225 degrees. Okay, so I can already see from this degree being negative that we would probably try to add one revolution or multiple revolutions in order to get this to be a coterminal angle between 0 and 2 pi that I can just look at. Okay, so if I add 360 to 225, just do the math. I get 135. Positive 135 degrees. Okay, which part of the quadrant would that be in? That would be in the second quadrant because this straight line is 180, so 135 would be over here. Again, it doesn't have to be perfect, but I do need to know which quadrant. Okay, why do I need to know the quadrant? Because I'm trying to find the reference angle. The reference angle is the acute angle that is formed between the terminal side, which is this right, the end of the angle theta that's formed, the end ray, and the horizontal axis. Okay, so how would you get theta prime, or the reference angle? It would be 180 degrees, which is the whole line, minus the theta, this theta. Again, we're given degrees, so we can use this one instead of having to use pi minus theta. Okay, so this is going to be 180 degrees minus 135 degrees. That'll give us the reference angle. So that's going to be 45 degrees. Cool. Now, 45 degrees. So what does this mean? This means that tangent of negative 225 is equal to, first we have to check the sine. Now where would 45 degrees be? 45 degrees would be over here. Oh, this one always dies. 45 degrees would be right here. All right, so in terms of tangent, remember tangent is sine over cosine. Okay, so think about the x values. So the x values would be positive in the first quadrant, and the y values would also be positive. Okay, and because tangent is opposite over adjacent or sine over cosine, it would be a positive divided by positive, which is positive. So this is going to be positive and equal to the tangent of the reference angle. And if you know how to do that, you would see that the answer is 1, because once you know this part of the unit circle, the x coordinate is the square root of 2 over 2, and the y coordinate is the square root of 2 over 2. Divide sine by cosine, and you would get the square root of 2 over 2 for sine, the square root of 2 over 2 for cosine. A number divided by itself is 1. Okay, so that is just 1. Okay, there's something very important that I need to go back to, so bear with me. So back to the recap, I added one revolution. It gave us 135 degrees as the coterminal angle, so that I could see which quadrant it is in. It is in the second quadrant. Okay, so it's this one right here. Let me make it a little darker for us. We found the reference angle, which is the acute angle formed between the terminal side and the x-axis. Okay, so we did that by doing 180 degrees, which is everything, minus theta, okay, which gives us 45 degrees. Okay, so this is going to be equal to the tangent of 45 degrees, but we have to be very careful with the sine. So I actually need to go back to that. So the sine is based on the coterminal angle, or the original angle given. Now the coterminal angle is in the second quadrant, so that's where we should have looked at. So the x value of the second quadrant is always negative, and the y value of the second quadrant is always positive. So when we get tangent, that's sine over cosine. A positive divided by a negative is a negative. So this actually should have been negative, and then make this negative, make that negative 1. Okay, so it could happen to anybody. We'll keep on practicing with this. Okay, but this sign, when you're making this original question equal to the same function, trig function of the reference angle, you do need to look at the sign, because the sign could be positive or negative. And that goes back to looking at where the original angle given is located, okay? All right, so let's keep practicing. Okay, so part C, 11 pi over 6. Okay, again, you don't need to draw all of this, but you should be able to see that 12 pi over 6, right, same denominator 6, is 2 pi, right? So 11 pi over 6 is going to be close to 12 pi over 6. Again, it doesn't have to be perfect, but I can see that it's going to be in the fourth quadrant. 1, 2, 3. Okay. So we're going to try to get the secant of 11 pi over 6. Okay, but we're going to use it by, we're going to solve it by using the reference angle. So the reference angle, okay, so remember that if this is theta, the entire angle formed until you get to 11 pi over 6, then the reference angle is going to be the acute angle formed between the terminal side and the x-axis, so that would be right here. Okay, so how do we get that? Theta prime is 360 degrees, which is the entire circle, minus the theta to get to this portion. Now, because they give it to us in radians, instead of using 360 degrees, we will use 2 pi. Okay, so basically 2 pi minus theta. Okay, so 2 pi, which is 12 pi over 6, so we spoke about that earlier. Right? You want to have the same denominator in order to subtract. Minus 11 pi over 6, and this is pi over 6. So the reference angle that we'll be using is pi over 6. So instead of secant 11 pi over 6, we are going to get the secant of pi over 6, but don't forget to check the sign in front. Now, in the fourth quadrant, what would secant be? Now remember that secant is 1 over cosine. And cosine theta is attributed to our x value. Okay, so what are the signs of the x values in the fourth quadrant? Those would be positive values. Okay, so that would be that this would be 1 divided by positive, which is positive. So this is going to be positive. Okay, so positive secant pi over 6. Pi over 6, you should be able to know where it's at. Pi over 6 is 30 degrees. And so what is 1 over cosine? I'm going to erase this now that we have it. So 1 over cosine, or in other words, 1 over x, is 1 over the square root of 3 over 2. And of course, you're going to do keep, change, flip. That's going to be 2 over the square root of 3. And then, of course, you need to rationalize that. So multiply it by the square root of 3 on top and bottom, and you get 2 square root of 3 all over 3. And we can ensure that this is a positive answer. Okay? That's it. Super fun. All right, so next we're going to move on to evaluating functions. And let's see. Yeah, I'm going to continue. I'm not going to pause the video yet. Again, review your trig functions, SOHCAHTOA, review the unit circle. All right, evaluate trig functions. Go for it. Part A, secant of 9 pi over 2. By go for it, we mean that you can just solve it. You don't necessarily need to find the reference angle, which is a little bit more work. Okay, so 9 pi over 2, you need to figure out what that is, where that is. So 9 pi over 2, you should be able to see that it is the same as pi over 2. Why? Because remember that 2 pi is over here, it's a full revolution, a full circle. And if you were to have a denominator of 2 and you do 4 revolutions, that would be 8 pi over 2. And then of course, another pi over 2 to get to 9 pi over 2. Whatever you need to do to find out the coterminal angle, the coterminal angle is going to be always good to use. Okay, so I can tell that this is the same as the secant of pi over 2, but if you don't want to do it like that, that's fine. Just remember what we were doing before. Okay, last class we were in section 5.1. We were taking away certain revolutions. And so we know that we could take away 2 pi, right? As many times as we want. So 2 pi, I'll rewrite that as 4 over 2, right? And so if you were to do that, you would get 5 pi over 2. And you're like, hey, I could still take away 2 pi. I could take another 4 pi over 2 away, and it would be the pi over 2 that we were talking about before. Again, if you could do it logically yourself and figure out where it's located, great. If not, you can just take away 2 pi again and again and again until you get to a coterminal angle between 0 and 2 pi. Okay, so what's the secant of 2 pi? Easy. Secant is 1 over cosine. Okay, so all we need is the x value. Remember that here you can pick any point. Okay, we don't have to do the whole thing that we were doing before about drawing the point on the terminal side. That point is x comma y. Get the trig function. Find the radius. Remember that for these questions, the radius is 1 because we're actually drawing a unit circle to find these answers. And so here I'm just gonna technically I have to pick a point, but this point would be 0 comma 1, right? Easiest point to pick on the y-axis. And so that means that cosine is the x value, which is 0. So it's going to be 1 over 0. Oh no, that's not good. What is 1 over 0? Undefined. Alrighty. At least we tried. Okay, the next one is the sine of a negative degree. Again, last time we were saying, hey, if you have negative degrees, we don't really want to have negative degrees. So what do? We find a coterminal angle that is positive between 0 and 360 degrees. Okay, so let's see if adding 360 degrees will be enough. Okay, I can see that it is not enough. Okay, so remember 360 degrees would be 1 revolution, 1 circle. 720 would be 2. And so let's just do this. If it doesn't work, we'll add another 360. Okay, so negative 510 plus 360 would be negative 150. So it's still not between 0 and 360. I can add another revolution, and that would be 210 degrees. In fact, I think we did this one in class in section 5.1. Okay, so 210 degrees, where is that located? Well, 180 degrees is right here. 210 degrees would be right there. Again, if you need a trig for the unit circle, start at 30. It's always 30. Add 15. Add 15. Add 30. Add 30. Add 15. Add 15. Add 30. Add 30. Add 15. Add 15. Add 30. Add 15. Had a moment there. Add 15. Oh, something else. Let's see. 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30, 30. My bad. 30, 15, 15, 30, right? Okay. And so 210 degrees, I'll do it in a different color. Would be right here. 210 degrees Alrighty. And so now we have to find the sine of 210. No problemo. So no problem. So sine of 210 degrees, that would be right here. Okay, so again, if I were, this is when I show you my trig for a unit circle. So let's get some space. Like I said, all you need to know is the first quadrant. So this first quadrant, let's use a different marker. This first quadrant, here we would have square root of 3 over 2, 1/2. Square root of 2 over 2 twice. 1/2, and the square root of 3 over 2. Okay, great. So now here, it would, obviously not the y-axis or the x-axis, but starting over here, it would be the same over here, kind of like symmetrical, but it's going to be depending on signs. So over here, the first quadrant, the x value is always positive and the y value is positive. Over here, the x value is negative, y value positive. Third quadrant, x value negative, y value negative. And fourth quadrant, x value positive, y value negative. Okay, so this is going to be negative for the x value, positive for the y. Negative for the x value, positive for the y. Negative for the x value, positive for the y. Okay, for here it's going to be both negative. Again, symmetry. So this one is negative square root of 3 over 2, 1/2. Skip the x-axis. This would be the same, just both negative. Both negative. Both negative. And then last but not least, fourth quadrant, x value should be positive, so this is going to be 1/2 negative square root of 3 over 2, positive square root of 2, negative square root of 2 over 2, and last but not least, this would be positive square root of 3 over 2, negative 1/2. Okay. Perfect. So for the sine of 210, I can see that it's negative 1/2. Just from knowing the unit circle. Now, if you don't want to draw the whole unit circle, then you could do what we were doing before, which is once we found the coterminal angle, we could find the reference angle and then just get the same answer. Okay, so I'm going to erase this beautiful unit circle, which hopefully you know how to write yourself. Do not look up a video, look up a picture. What we're going to do is what we were doing before, which is 210 degrees is clearly in the third quadrant. Find the reference angle, which is the theta prime, the acute angle formed between the terminal side and the x-axis. How would you find that angle? It would be, always helps me to draw the original angle, theta. It would be theta, just everything, minus the 180 degrees, which is the straight line. Okay, so this is going to be 210 degrees minus 180 degrees, which is 30 degrees. Okay, so this is going to be the same as 30 degrees, which we spoke about that in class as well, section 5.1. And 30 degrees is not hard to know. Okay, that the x value is the square root of 3 over 2, y value is 1/2. But again, double check in the third quadrant, what would be the y value? Remember that sine is y value. Well, the y value would be negative. So then this is going to be, I erase this, the sine of 210 is the same as negative sine of 30, which is the reference angle. And the sine of 30 degrees is 1/2. Don't forget the negative in the front. Either way, you'll get negative 1/2. Okay, so for these questions, if it's specified to you to use the reference angle, use the reference angle. If not, you could draw the unit circle and do it that way. I definitely don't mind. But as you can see, it is helpful to use reference angles because it's going to give you, it's going to allow you to go back to the first quadrant most of the time, which is very easy to know these coordinates. Okay. Again, do what works for you, but you gotta know it all. Okay, so now I'm gonna pause. We're almost done.